I'm sure it's not exactly a secret that I make a lot of helmets, paint them, then display them, so naturally I end up needing a lot of helmet stands. I've had different methods of making them over the years in varying complexities, but I always wondered if I could improve it further, making an entire system that's modular to work for whatever helmet or purpose I need it for. The part that ends up being the most tricky is the pole, which I know you might think would be the easiest. It's the one part on all my more recent helmet stands that I haven't been 3D printing, either using an acrylic tube or a wooden dowel. You then need to have those parts around to be able to make yourself more helmet stands, and also a decent way to be able to cut them down to the size you need. This design is my hopeful solution. It uses a screw system to attach multiple parts together so you can combine however many you need to get the pole length you want. They are reasonably tall pieces though, with not the largest bottom surface area, so I was a bit worried that I wouldn't be able to successfully print these without the use of a brim, or they would just, constantly want to be falling over when being 3D printed. So I ran them on a bunch of different printers, and so far everything has printed perfectly, even on my A1 Mini. How well do these work together though? Honestly, pretty smooth sailing for a fully 3D printed system. They also don't require any support material, and they're a pipe design, so not solid in the middle to increase walls and hopefully overall strength of the piece. You've also probably noticed that I've been printing them in a few different sizes. I figured having a small, medium, and large sizes to choose from would be the easiest way to get exactly the length everyone needs. But of course the pole isn't the only part needed for a helmet stand. We also need a base and top cap. We're going to start with the caps. I wanted these to work as part of this system with the screws so that you can flip them out and change them as needed, and in a variety of types since there are so many shapes and sizes of helmet. Sometimes I find that the top caps having straight edges can help keep the helmet where you want it, so we've got a couple sizes of those, and then there's the rounded versions. These end up printing right side up, so the rounded edge and top prints super smooth, so there's a little bit of support material to remove underneath. I really tried to design everything to not need the use of support material just to keep the waste as minimal as possible, but there are a couple of pieces in the system that require just a little bit of support material, and these screw onto the pole parts just as easily as the pole pieces screw together. Now onto the bases for these helmet stands. I had about 20 ideas for how I could go about these bases in varying complexities, and we're going to design most of them. Starting with the easiest, just a simple base stand. I wanted there to be at least one option that would be able to fit on any smaller 3D printers like an A1 Mini, or if you just wanted a smaller, less obvious base in general. I then went ahead and created a larger version for anyone wanting or needing their base to be a little heftier. The other nice thing about this being a fully 3D printed system is you can easily choose the color you want it made out of. I decided to be boring and stick to black for mine for this video, but it's something that can be so easily changed depending on your preferences. You can start to see here the complete system between the base, poles, and top caps and how it all works together. I would like to mention this Merrick helmet is easily one of the heaviest helmets I've ever made. It's almost 2 kilograms of solid resin, and this small base has absolutely no issue with keeping this helmet stable. Now those bases are all fine and good, but for displaying helmets, it can be nice to have a bit more of a complex, customized design. So I came up with this system. You have this fairly standard base piece that has the screws built in, just like the other ones. It's kind of just like a modified version of those first designs, but there's this space for a design disc, I guess we will call it. And this disc can be customized to whatever design you want. It just seemed like the best way to go about this so that you're only having to look at printing this flat, smaller disc piece instead of an entire stand base. I'll be releasing the plain model of this disc so that any of you can customize it to whatever design you like. I've already done a bunch. I'm sure I'll be continuously adding more, but I also wanted this to be like an open source project for whoever wants to add to this idea. I also figured it would be helpful if I actually showed you how I've made all of these designs so that you can customize your own. I'm using Fusion 360, but you could technically achieve the same end result in a slicer like Bamboo Studio or Orca. It would be a little more convoluted of a process. Before Fusion, I've got the base disc model here already, and I'm going to go up and insert an SVG. I'll link below the website that I typically use to convert PNGs to SVG files, but this basically imports as a sketch into Fusion that you can then rescale, move around where you want it, and you can then create a 3D geometry from. Once I've got this mythosaur symbol where I want it on this disc, I can press Finish Sketch and start to select the parts of the design. Once they're all selected, we can start extruding this. this. I've been keeping these designs at 0.6 millimeters, so 3 printer layers of color, and you want it to be negative so that it's flush with the disc and not extruding from it. Fusion will default to cut, but we want to change this to new component and then press OK. This will create a new component, and to this group I'm going to add a copy of this disc. Now all of these separate pieces can be exported as a single STL while still keeping the design data on the flat disk for us to recolor in our slicer. This could obviously be printed in whatever filament colors you want, but to keep with the Boba Fett theme, I'm going to go with an olive green and red. I personally prefer the design to print as the first layers, so it's nice and smooth, and after all of that, we can send this model to print. Because this is a flat design, it only involves 4 filament changes to print, so again, as minimal as I possibly could be in the waste department. Once your disc has finished printing, you can add it onto the main base. It sits perfectly flush with the rest of the base, and from there you can continue to add parts to build the stand to your specifications. At some point during all of this disc designing, I realized that the empty area of the base piece could be the perfect spot to add some lights to, so I modified the base to have a hole in the side for a cable and got it printing. It only seemed right that this light up base would have a Death Star panel theme to it. For this disc, I made the white slots a lot thinner than the rest of the disc so that the light would be able to shine through them. First, we need to install some LED lights into this base. I'm just using a USB LED strip for this, made sure to feed the cord through the side hole, and then stuck the strip around the inner wall of the base with the excess going towards the center. You could even print the bottom of this base piece in silk or white filament for the light to bounce off of even more, but even in black, this still worked great. And just like all of the other bases, it has the screw attachment for you to add whatever length of pole to and your top cap. This final base was by far my most ambitious and something I truly did not know if I would be able to get to work. Just as I need helmet stands for displaying, I also need them for painting, and when I'm painting, I need them to rotate. So I wanted to see if I could make a fully 3D printable turntable version of this base stand. The first bearing test piece did actually work better than I was expecting, but I tried barrel style rollers and they ended up rotating within the frame pieces, causing the bearing to lock. This did give me hope though, because ultimately it still could rotate quite well. I knew that it meant I was going to have to give actual ball bearings a try though, because if they rotated within the frame, they're literally a sphere, so it wasn't going to affect it. And here is my prototype for that. Because there are a bunch of free-floating balls in this bearing, there is a support material ring that needs to be removed from the bottom. This could take a bit to remove depending on how dialed in your filament settings are. I can tell you it came off a lot easier on this second piece compared to my prototype, but once you've got it cleaned up, you should be able to have this bearing rotate quite smoothly. To make it even smoother though, I did decide to add some lubricant to the bearing. And this worked so much better than I was expecting. It was so satisfying to spin this bearing around, but we can't be distracted by this forever and need to put this into a base piece. I went with a 2-piece cover design to attach to the bearing. First is this bottom base, which I printed to be super heavy so that it wouldn't want to slide around when you're rotating it. I am going to go ahead and glue these parts together so that everything is very secure. The bearing piece has an extended edge on the center ring. This is technically the bottom of the bearing and what needs to be glued to this base piece. I'm just using some super glue for this, going around the outside of this ring with the glue and then a little bit into the crevice. I'm also going to glue on the top of this turntable stand. This time you only want to apply glue to the outer larger bearing ring. The one thing with this version of the base is I had to design it without the screw attachment in the center. It's a long story, but it just wasn't working with this version because of the orientation it has to be printed in, so you'll also need to glue a pole segment into the center hole. The rest of the stand stays modular though, and you can add and take away however many pole pieces you want from the permanently installed piece. And those are just a few examples of what you can do with this helmet stand system. Thank you for joining me through this design process. All of the parts should be available now for you to print yourselves if you'd like, and I'm sure I won't be stopping here with this concept. So if you have any recommendations or requests, please let me know. I cannot wait to see all of your helmet stands. Thank you so much for watching, and I will see you in my next video.